Good morning, class. I am so glad that you are here today because you are going to have a learning experience that I think you'll remember for the rest of your life. Now, before we get started, we will be taking a class vote on something. Pizza Barn offers a 6-inch thick crust one-topping pizza for $5. Pizza Barn offers a thick crust one-topping pizza in the 12-inch size for $10.99, or we'll say $11 because it's closer to 11 than 10. Again, the 6-inch is $5, the 12-inch is $11. Which do you think is a better value? I want you to write your answer down, either 6 or 12. Put it on your paper, and at the end of the class period today, we'll see if you still have the same idea. Before we get into our actual working part of the lesson today, let's look at our old friend, the KWL chart. K standing for what we know, W for what we want to know, and at the end of the day, one of you will fill in the L column what you have learned. Now, let's start out. Yesterday, we went over the formula for various shapes. Brendan, how do we determine the formula? What is the formula for finding the area of a circle? Correct. It's pi r squared. And what is the numeral that we write out to designate pi? Yes, Brendan, it's 3.14. All right, very good. Now, what is it, Dylan, that we want to know today? How to determine which size pizza is the better value. If you don't like pizza, you just think about quesadillas or some other food that's round, and it works out the same. Okay, now one thing I want to tell you real quickly with your pizzas. Pizzas are measured in diagonal lengths. And the reason for that is, probably many reasons, but one thing is pizza is cut all the way across, all the way diagonally. You don't see people take a pizza and cut it from the edge down to the center and up again. It's not measured in radius size, it's measured in diameter size because the pizza is cut all the way across. So remember that. And the radius doubled is your diameter, or the diameter divided by 2 is your radius. Remember that now. Okay, so a 6-inch pizza has a radius of what, Isaiah? Yes, 3. And Caitlin, a 12-inch pizza has a radius of what? 6. Very good. Addison, an 8-inch pizza has a radius of what? 4. Very good. And Jessica, what would be the radius of a 5-inch pizza? You're correct, 2.5 inches. All right, now our next chart to look at is not a cheat sheet, it's a shortcut sheet. And I will have this enlarged and put on the board for you. It's just a refresher of numbers that are squared. And what does squared mean? It's a number times itself. So for example, Jennifer, if the R is 3, what's the diameter? Yes, 6. And if we want to square 3, what do we get? A 9. It's not times 2, it's times itself. All right, Daniel, if we wanted to square 6, radius 6, and we want to square that, yes, it would be 6 times 6, which is 36. And with your list, you'll notice that the radius 3, which is a 6-inch diameter, and your radius 6, which is a 12-inch diameter, I have each of these highlighted. So you can refer to this in your computations. Now, you will have some pairs to work with today. You'll be on your grid paper. I put grid paper on everyone's desk. You all have some grid paper. You will be drawing an 8-inch circle, and on top of it, the 4-inch, 8 and 4. You'll also, on another sheet of grid paper, be drawing a 6-inch circle, or tracing it, I should say, and then the 3-inch on top of that. And then you'll go back and use your 4 again, and on top of that, you'll use a 2-inch circle. And what you'll do with all these circles is I want you to calculate what the area is and write it out to the side. But here's the thing, even though I gave you 6 circles to work with, the 2 and 4, the 3 and 6, and the 2 and 4, you really only have to figure the area of 5 different circles because the number 4 circle gets used twice. Now, after you do all your computations on your paper and then you're drawing all your circles on your grid paper, then we get to the fun part of the assignment. The fun part of the assignment today is this. Each of you will take one sheet and design a menu for me. Be sure that you put your name on the back. Before you even start, be sure you put your name on the back. Your menu will have 5 different items. Each item will be 2 different sizes. All right, for example, what are some round things you might order in a restaurant? Isaiah. Yes, quesadillas. All right, Brendan, what's something else? Donuts, very good. All right, Carlos, what's something else that's round? Pizza, very good. All right, Amelia, what's something else that might be round? Yes, a bowl of soup, very good. All right, so you've got, oh, I'm thinking of something else nobody's thought of. Something that you might put syrup on. Daniela. Yes, pancakes. So what you'll do is you'll have 5 menu items. Each will have a large size and a small size. I want you to decide your sizes using the circles you've measured today, like either a 2 and a 4, a 3 and a 6, or a 4 and an 8. Those will be the sizes you work with. But you get to play around with your prices. So I want you to determine that sometimes the small one will be a better value, sometimes the larger one will be a better value. It all depends on what you price it at. And on the back of your sheet, along with your name, number it 1 through 5. And for number 1, is the larger or the smaller one a better value? Whichever one is the better value, write it on the back, 1 through 5. Any questions? All right, and at the end of the day, we're going to see if you can answer that question about which was the better value. Okay, and if you have any questions as you work, you may quietly ask the person next to you or raise your hand and I will certainly be happy to help you. Okay, you may begin. All right, class, it looks like everyone's finishing up here. Let's go back to our question we had this morning. Is the 6-inch pizza the better value or the 12-inch? What do you think? Marcus? You think the 12-inch? Okay. Rosa, what do you think? You think the 12-inch too? Well, does anybody think the 6-inch is a better value? Well, why not? I want somebody to give me an answer. Isaiah. That's exactly right. Even though 6 times 2 is 12, when you're working with area, when your radius doubles, the amount quadruples. And let me show you again visually how you can remember that. Because here was your 8 inches, here was your 4 inches. And we had the difference above it, below it, on one side and then on the other side. So it didn't just get larger at the top and the bottom, it also got larger on each side. Does that make sense? Okay, now tomorrow we have a mystery question to go along with today's lesson, and be sure that you go home and teach this lesson to someone else. Any questions before we dismiss for the day? Okay, great, and I'll see you all tomorrow. Goodbye.